Now, we talked about the wedge a few times. This is going to run a bunch of samples or a bunch of different values for different parameters, and we didn't actually set that up yet. So let's go over to that parameter over here. This is the one that we want to vary, because remember that this is driving the seed on the particle sim and the seed on our turbulence. So let's just put this here. We actually just want the, oopsies, we want the path itself without any of this expression business here. We'll call it seed, which is fine. Again, the important thing is that this is this. If you hold your mouse over it, that's the seed parameter. We want it to do, let's have it do 5 different ones, and not random samples. Let's have it do 0, 1, 2, 3, 4. So including 0, that's 5 different samples. So to reiterate for the 16th time, this is going to run this output driver, this guy. It's going to run it 5 times, and every time it's going to set this parameter to 5 uniform increments between 0 and 4, which is 0, 1, 2, 3, 4. So it's as if you set this to 0, ran this thing. Set this to 1, ran this thing. Set this to 2. This is especially powerful when you're working at a studio, when these can be run in parallel. It could be run on 5 different machines all at the same time. Now, unfortunately, you, and especially I, probably are using their own personal computer right now. So it's going to probably have to run one after another. But still, you run these overnight, that's still a pretty good deal. So you might be wondering, if it's running this thing 5 different times, isn't it going to overwrite this file 5 different times? Well, yeah, actually it will. What we need to use is a variable that will change with each wedge. And that variable is called wedge. Easy enough. The wedge variable will be set to a combination of this prefix, underscore wedge, then underscore this name, and then underscore the value that it ends up choosing. So right now, that wedge is not set to anything. So you can see it just says cache v1. But once we run from this guy, so it's really convenient. If I just want to run this, well then it doesn't matter if the wedge is there. But if I run from this, those wedge values will be put in. Great, so I just saved it again. The last things I want to do before we run is, let's just take a look at this one more time and see what changes, if any, we want to do. Right off the bat, I would say we can see that it's running into the wall here. I've kind of been ignoring that up until now, but now we might as well do something about it. So let's go over to the simulation and actually let's make those, because it's on these sides, the ones that are facing us, that we're going to see it. Let's not make it any wider in the back. Let's just make it wider in the front. So we can interactively do it, of course, and just drag it forward. I like, for the sake of you guys following along at home, I'm gonna do it interactively like this, but then I'm gonna actually I'm gonna set it myself. So I can see I pulled it this way a little bit. We're approaching 12 on this, so I'll just set this to 12, and you can see on these we're approaching 1. So let's just set these to 1. So now it's essentially just added 2 more units of space towards us. So that won't slow it down too much. Because I'm going to run this overnight, might as well set the divisions to 300. When going from wedges to, our final resolution will be 600. But I don't want to jump from a wedge that has uniform divisions of 150 all the way to 600 for my final product. That's a pretty big leap. Your simulation can do different things as it gets up-resed. A jump of a factor of 2 shouldn't disrupt the shape too much, but a factor of that 4 could. So 300 will be good, and again, anyway, it's going to be overnight. Also, this turbulence, I was thinking about it. Remember, we used the turbulence to make these general shapes, these big features. I think it would probably be better if we don't introduce too much actual turbulence like fractal, like small features into our turbulence. We'll let now that we have these disturbance microsolvers in here, we'll let them take care of the small stuff, and let's just have the turbulence itself be bigger features. So that's why we're setting it down to 2. And finally, looking back at this guy, something that happens, the disturbances can be hard to wrangle sometimes, and this did a pretty good job. I'm not too worried about it. But sometimes, like towards the end, it can just get really fuzzy. I tried to tamp down on that by saying don't affect velocities whose speed is lower than 0.5. Maybe we could increase this to make it matter even less, or even easier, and I'm going to turn our solver or our simulation off for a second, we could just animate it down. Like we know, because we always have the ability to art direct, we know that the main things we want the disturbance to do is to break up these leading edges. And once we kind of get to here, maybe, it's done that. So I would say starting maybe almost even a little earlier, maybe at 45, because we're going to ramp it out. So it'll still have some by here. Maybe starting around 45, we might turn off the disturbance. So maybe from 50, okay, we'll keep it on a little longer. Maybe from 50 to 60, it turns off. All these little features will still exist. They're not going to disappear, but it would be nice to we could just have them move on their own at that point. Instead of, like, I can still see it getting broken up into little pieces over here, which concerns me. So let's just have it start ramping off around 50. And then by 60, no, I'm going to go back on that. 45 to 55 I think is good. And then it can be off by then. So I'm just going to select all 3 of these at once. We'll just key this guy at 45, because that's when I said we would start turning off. And then by 55, we'll have it be off. Cool. And that's just an art direction choice. I've just seen that happen too many times where, especially the higher resolutions, we're not even seeing the effect of this guy that much right now because his block size is smaller than the actual voxel size that we've been doing. But I can already tell that it's gonna get grainy and weird. So anyway, so now they're gonna get turned off. We upped our voxels. Everything else is good. The turbulence, we took down the turbulence a little bit. That should do it. Let's double check that we've got to the rest field stuff. Ba-bam, ba-ba-bum. Cool. Great. That's basically it. So let's run out these 5 simulations. It's going to take up some disk space, but that's not really a problem. And I'm going to turn this off too. I don't need to see that anymore. And away we go. See you tomorrow.